If a relation qualifies to be a function, then we can move a step deeper and investigate if the function has properties such as being one-to-one and/or onto. If a function satisfies both properties, then it is called a one-to-one correspondence, or one-to-one onto function. When such a case occurs, then we are able to find the inverse of a function. And this inverse function is able to undo the action of the original function. In this section, we will learn more about one-to-one and onto function, followed by the inverse function. In this subsection, we'll define what one-to-one functions are, and we will also work on some examples of one-to-one functions. First, let's define a one-to-one function. A function from set x to set y is one-to-one if and only if, for all elements a and b belonging to x, if f of a is equal to f of b, then a is equal to b. What this is saying is that for any elements a and b in x, if we put a and b under function f, this is what we get. However, if f of a and f of b are the same image, then the only way this can happen is if a is equal to b, or they must come from the same point of origin. If we say it the other way around, we would have this. If a is not equal to b, then f of a is not equal to f of b. This is the contrapositive statement, which is perfectly equivalent. Based on the definition, we can deduce that if f is one-to-one, then every input has a unique output, or every element in the domain has a distinct image. So they cannot share the same image. And when will a function not be one-to-one? If there exists a set of elements a and b whereby f of a is equal to f of b, but a is not equal to b, meaning they share the same image, but their point of origin is different. In this example, we are to identify the one-to-one function. In part A, we can see that b and c share the same image. So f of b is the same as f of c, which is 3, but the points of origin, b, is different from c. Therefore, this function is not one-to-one. In part B, we can see that a gets mapped to 4, b gets mapped to 3, c gets mapped to 1, and d gets mapped to 2. So each element in the domain has got a unique image. Hence, the function is one-to-one. In this example, we are given functions f and g presented as f of x equal to some image. It is helpful, but not necessary, to use the arrow diagram. For function f, 1 gets mapped to r, 2 gets mapped to q, 3 gets mapped to p. We note that each input has a unique image. Therefore, f is one-to-one. For function g, 1 gets mapped to s, 2 gets mapped to r, 3 gets mapped to s. With an arrow diagram, it is easy to see that inputs 1 and 3 share the same image, s. Therefore, we conclude that g is not one-to-one. When stating your reason, the counterexample must be clearly stated as shown. In summary, to prove that f is one-to-one, you need to know that for all A and B belonging to domain X, if f of A is equal to f of B, then A is equal to B. Essentially, you need to go through each and every input to make sure that they all have unique output. To prove that f is not one-to-one, then show that there exists a set of elements A and B whereby f of A is equal to f of B, but A is not equal to B. Essentially, you need to find a counterexample A and B such that they share the same image, but their point of origin are different.